presentation here now. Welcome to this Finland Azure User Group Tips and Tricks presentation. This is actually the last presentation before our summer break, so I'm happy to see so many people here joining already. Finland Azure User Group, as you probably already know, is the largest tech user group in Finland, and we have almost 1.9k members at the moment. So please visit our meetup page. You can find it with just Finland Azure User Group there. And well, this YouTube channel has all of our previous presentations that you can go back to. And these tips and tricks presentations are often short or 30 to 60 minute presentations that the presenter kind of shows something that they have recently learned related to Azure, basically. So with no further ado, I will let Yuri, who's the presenter for today, to take the stage here. Go ahead, Yuri. Yuri, one more thing. I think we actually have some issues here. Let's go back to the presentation, or the startup. I think we might be on mute. So just a moment. I think I fixed it. Let's continue. Sorry about that. Start again. Yeah. No.
So from the beginning.
Yes.
Okay. So hello everyone again. This is Virtual Azure Tips and Tricks session, where I'll be talking about how to manage Azure infrastructure at scale. Pasi, now I hear my own voice within it. Is it okay? Is it fine? Like it repeats after some time my voice.
Yeah, it should be fine now.
Okay. It's just kind of like slowly repeating, a bit disturbing, but let's try it out. Okay. Yes. So the session is it still repeats. So okay. So okay, let's try it out. No, Pasi, it still comes and goes. Do you want that I'll reconnect? Try to reconnect.
I wonder where it's coming from.
I mean, I just hear my voice all the time. So I'll maybe try to reconnect.
Do you have the stream open on the background now? Because that might be.
Just a second. Or actually, yes, sorry. Yeah, this was my mistake, most probably. I didn't mute the stream that was ongoing, so yeah. I guess that was it. Yes, so yeah, hopefully now this will be it.
Yes, thanks.
Hello again, everyone. Welcome to Finland Azure User Group Virtual Azure Tips and Tricks session, and where I'll be talking about how to manage Azure infrastructure at scale. So about myself, I'm cloud architect consultant at a company called CloudBro. I've worked with Azure a bit over 3 years, with 10 years of experience in web development with various languages, and mainly for the last 5 years I've been focusing in cloud and big data, microservices, and Kubernetes. And currently I work for a client that many of you are familiar with. It's Tietoevry or Tietoenator previously, and I work for data and analytics in healthcare organization there. And there are many open positions, so please take a look, follow the link, and if you like the presentation and technologies, maybe you would like to join us. And there are around 50 professionals in the organization, in our team. We work with Finnish healthcare customers. We build Azure-based healthcare data platforms and products to support use cases like mentioned lower, like data science, research, machine learning, analytics, business intelligence, and so on. And of course, taking into account the security and privacy requirements of our regulated healthcare domain. Quite interesting domain. So, and the overview of the session. So we will start from the problem definition to make it clear what we are trying to actually achieve or build, what's the problem. Then we will take a look into the Terraform tools itself, like Terraform, Azure DevOps, and we will try then to put all it together. And we will see some demos as well, like along the way, and like in the end there will be a big demo. So I'll try to cover the slides as fast as I can. Then like main presentation will be mostly in like demos actually. So let's start from the problem definition and the first talk about actually cloud migration. What is it? So cloud migration is a process of moving digital assets to cloud infrastructure, and there are various assets, data, workloads, IT resources, applications. And a migration may involve moving all or just some assets. By moving or duplicating in majority of the cases, when you duplicate your data assets to the cloud, you can start building a cloud data platform to support those various use cases that I mentioned already earlier. And like benefit from the data, and you don't really need to do the whole migration of everything what you need if you are having a lot of resources on-prem. And now let's concentrate on the data platforms themselves. So a cloud data platform usually consists of multiple subscriptions. Each subscription usually contains one or more virtual network. And the most common way to provide connectivity between those virtual networks and on-prem network is to implement hub and spoke network topology. You can see like the reference architecture from Microsoft for it. And on top of networking, each of the subscriptions will contain like tens, hundreds, or even like thousands of resources like VMs, databases, and storages. So sounds somewhat complicated maybe, but that's not it. And just to mention, like mostly multiple subscriptions are used like for covering multiple environments like dev, test, prod, or like splitting by the department organizations, let's say mostly, and to isolate those workloads from each other. So on top of that, the problem is actually for us is that when you have multiple customers who want to have a build that you will build and manage like their cloud data platforms, and there is like a very small team that is going to do that. So you need to really do it on scale and try to cover all the customers, and with really small team support all of their use cases. So let's now take a look into those like different tools that we can use actually to achieve the goal, or to what can help us in that. So Terraform is the first one. So what is Terraform? It's an open source infrastructure as code software tool that provides a consistent CLI workflow to manage hundreds of cloud services. And Terraform codifies those cloud APIs into declarative configuration files. You write your infrastructure as a declarative configuration using HCL language. So it's a language of HashiCorp. Then you run the Terraform plan to check what are you actually creating, if everything corresponds to what you are trying to achieve. And then you apply changes to those hundreds of cloud providers with Terraform apply to reach the desired state of configuration. That's like actually Terraform will take care of creating, communicating through APIs with those cloud providers and creating all the resources that you need for you. What are the providers? So providers are like logical abstractions of those upstream APIs. So they encapsulate, they implement the API, and they are responsible for interacting with those various APIs to negotiate on your behalf, let's say, the resource creation and achieve what you are trying to do. There are multiple like implementations of those providers for a public cloud, like AWS, Azure, GCP, and others. Then there are some open source providers like Kubernetes, Helm, Databricks, Consul, and many others. And like maybe here to mention that this is maybe one of the main purposes why you would go with something like Terraform and not Bicep or ARM templates, because those are mainly created for covering Azure itself, and not really like any third-party resources or APIs. But Terraform through the providers provides like integration with various like this open source tools like Kubernetes, Databricks, Helm, and also like public web services like Artifactory, Auth0, and Cloudflare, for example. And at the moment, there are around 1,100 providers available. Of course, they are on different states. Some of them are like more official ones. Some of them are just some hobby projects, but there is quite many. And like you can search and see, there are even like many implementations of the same APIs, let's say, by different people with different adoption levels, let's say. And another like important part is the state or the state file. So Terraform records infrastructure about what information about what infrastructure it created in a Terraform state file. It's stored by default in a local file named Terraform TF states. Then it has a like custom JSON format for recording that infrastructure representation. And Terraform uses that local state file to create plans and make changes to your infrastructure. So to compare what you have, what you are trying to create, and show you through the plan what are the differences and what it's going to actually be doing. There are some competitors. There is Pulumi, which is Azure SDK based, and it's like a code native, as they call themselves. And the code native is like, point of it is that you can use power of familiar programming languages like mentioned here. And they're like provided tools of those languages to define your infrastructure compared to custom DSL like HCL, for example. Then there is a Bicep, which is the DSL over ARM itself, and it's kind of, at the moment, it is Azure-centric to cover kind of Azure resources. That's the main purpose, I guess, of it. And there is like experimental, this is not a competitor, but Terraform, like because Pulumi came up with the code native, they are code native, so there is no like really any DSL over the language. You just use programming language. They have experimental now CDK, like Cloud Development Kit, to give similar functionality, but it's for now still experimental. So, but most probably at some point it will be production ready. And you can find here some information about their comparison, like how they, like what's the difference in between of them and how they differ from each other. And let's go to to have a small demo of it actually. So I'll be, let me see. So yeah, here I have Terraform demo, and here is my environment. So here is my subscription. Don't pay attention into this like resources that they are just for a backup reason. If something goes wrong, that I can use those created ones already to show you some demos. So I will be now trying to run this demo. So here we have a small configuration file. So actually we don't really need those files, but yeah, so it's just one file, main TF. Here we are describing the required provider. And because we are interacting with Azure resources, the provider we are going to be using is called Azure RM. So here you see version. So this is for the newer version of Terraform. This is like a required block that you need to provide. Here you can provide some various configuration for your Azure RM provider itself. If there are multiple of them, for example, if you use like 2 different subscriptions from one project, you will need to define like 2 of those. And what we are trying to do is we will try to create a resource group called Demo RG in North Europe. And we will try to create in that resource group Demo VNet virtual network with specific address space. So for that, first we need to run under this folder Terraform init. So this will initialize actually. So this actually looks into your provider configuration and downloads all the needed versions of the providers that you can work with them locally. And now we can run Terraform plan. This is the first command, which will go through your configuration and exactly check what needs to be done. And it will compare your plan with the state file that you have, but we didn't have any state file before. So like we have empty state, so it will kind of like plan will show that, yes, so we can see the plan. So plan shows that we are going to create 2 resources. There are no any changes, nothing to destroy, and it will create a resource group and a virtual network. And now we can say Terraform apply, which will do the same. It will first run the plan. It will show what is it going to be executing, and then you need to say yes to it. There is no interactive way to run the same command that you don't need to like specifically say yes to it. So it asks, it shows the same stuff, and here you need to say yes. And now it will actually communicate with the APIs and actually deploy everything what we want, and we should see our resource group soon appearing here. And maybe to emphasize here, if you are having one big Terraform project where you are managing all your resources within one subscription from one Terraform project, then if you have like hundreds or thousands of resources, then your plan is going to be going very slowly, like because it needs to go through everything, check the state of it, compare it with what's in the cloud, compared with state files. So it gets very sluggish and slow. Of course, with the newer versions of Terraform, there are some optimizations and so on, but still it's like there is issues if you have like a lot of things done within one Terraform project and which are managed through like one state file. So now we have that applied. So let's take a look and see if resource group got created. There is of course some. Yes, so here our resource group, and we can see that we have the demo virtual network created. So meanwhile, I'll switch into, but I'll destroy this because we don't really need it. So if you want to get rid of those, this is something what you most probably don't want to run actually in your production environment. But if you are just experimenting, you can just run Terraform destroy, and then it will just destroy everything what you have created for your configuration project. So let's just wait and say yes, and then I'll switch into the presentation. So yes. So that's a small demo. And some tips, let's say, about how to organize those Terraform configurations. So there are multiple strategies. So you can use one Terraform project for the whole subscription. And as I mentioned, it's like the plan is becoming slow while your project grows and resource amount grows. You can use like directories. There are like workspaces within Terraform for separating environments. But we, for example, don't really use your workspaces. We just actually have different subscriptions for dev, test, and prod, for example. Then you need to create actually, or you can create modules. You don't need to create. Modules are like self-contained pieces of infrastructure as a code. So if you have a thing that you if you, for example, create quite many times within different projects, like Key Vault with some storage account, with something else, and then you always have the same configuration for them, you can actually create a module for creating all of those resources and expose it through just a specific set of variables that will define, for example, naming convention there or names, and that's it. And underneath, like module will take care of creating and wiring all those resources together. So this is a very powerful thing actually. So definitely use the modules if you can. And then storing the state files in a shared storage that all of your team members will be able to access it. Or then if you are using like Azure DevOps or some other CI/CD pipelines, that they will be remote and not on your machine. So as I kind of try to show here, maybe we can take a look into that. Terraform state file is saved in your machine in this case when we are executing it from my machine. So only I will have access to it. If someone else would need to use this, though you will have like, maybe you can share it through the Git repository, everyone will have access, but the state file usually contains a lot of like secrets, and you don't want to store it in the Git repository, definitely. We can take a look how we can do it using some remote shared storages. And yeah, there are many others. So this is about Terraform. I think this should be enough for us. And then we will go into the Azure DevOps. So there are the Azure DevOps consists of 5 main components. There are Azure pipelines, which is just the normal CI/CD that you will find in anywhere, whoever provides like CI/CD. So you can connect different repositories, any kind of Git repository, and use any kind of language. There is Azure boards, which is mostly for project management, Kanban boards, like Scrum boards, and so on for reporting. Then Azure artifacts for Maven, NPM, and for any kind of package fits. Then Azure repos. This is like your Git repositories and collaboration tools for pull requests and all of those. And Azure test plans. This is testing related. And we are going to use Azure pipelines and Azure repos, so you don't really need to know much about the rest of them. And there are over 1,000 extensions available for you to use. Like here you can find some. So Terraform is actually yet another extension, but though we are not really using it because we have a custom solution for it. Yes. And to build our solution, we will use the following list of resources from Azure DevOps. So on high level, we have the organization and the projects, and under them agent pools. We are using self-hosted agent pools. There are also Microsoft managed agent pools. Then repos, YAML pipelines, and environments. So this is kind of pretty big part of the whole setup. So let's take a look into Azure YAML pipelines. So here we can see the structure of the pipeline, and the pipeline is one or more stages that describe your CI/CD process. And a simple pipeline can be consisting only of steps. You don't really need to have so nested structure. So you can have just, if there are 2 steps that you run, for example, Docker build and Docker push, then you can just use steps actually. And here is exactly example where you which does for you the Docker build, for example. This is example of the YAML pipeline. So your pipeline can also be committed to Git repository, and you can like have it with your code, and that's what actually we are doing. And now let's try to put it all together. So we've seen Azure DevOps, we've seen Terraform. So now let's concentrate a bit more on the Azure DevOps part and the Git repositories and how we will structure our project. So overall architecture is like this. So high-level architecture overview of all the DevOps resources that we are going to be using. So we will have one organization from where we will manage all our clients. Per client, we will have a DevOps project created. Those are in the middle, the projects. So every customer will have their own DevOps project. Then each environment of each client will have a dedicated Git repository where we will keep like Terraform configuration corresponding to that specific environment. Each repository will consist of multiple Terraform projects. So we are not going to go with like monorepo. We will have like a small Terraform projects that are going to kind of work together. And each Terraform project is going to have its own Azure YAML pipeline for running Terraform plan and apply. And each customer environment will have own agent pool with agent running in corresponding customer environment, which is tied into that specific project and the kind of Git repository. So here you can see like how it is distributed. And for this, we have actually like 2 templates that we will be using. First one is actually to bootstrap those resources within the customer environments. And for that, you need whoever is doing a bootstrap, he needs himself to have access to that environment, of course, and specific permissions. And when the infrastructure, Terraform infrastructure resources are in place, then we will start actually building this structure, which is in the organization part. So which will have like different Git repositories and the projects, and which will be using the agents which are deployed in the subscriptions of our clients. So repository structure and realms. Yeah, so as I mentioned earlier, there are multiple ways to structure your Terraform project code. And one that we are using consists of so-called realms. Realm is a collection of smaller projects that belong together, that kind of together form some kind of entity, let's say, or do together something. So as an example, you might have a realm called core, like what we have on the picture, which will contain core components of your data platform, like networking, data storages, zones, monitoring resources, and subscription configurations. And then another example is like integrations realm, where you can like everything concerning integrations will be under its own realm as such and will be managed through a set of like projects. Usually we have a project under each realm, which we call like common. You can see others are connecting to it, and where we create resources common to all of those like projects underneath the realm. So for example, you might have like some key vault, which contains secrets used in many other projects. So you will create that as a key vault under the common project. And usually we tend to have one common realm that we call core, and that's the top one that other realms depend on. And core realm is the backbone of the platform. So that's the one which creates a core of the platform that others can utilize. Again, like networking, for example, will be there, because everyone will need to use the networking to create some resources like VMs, maybe subnets, and so on. So those are the like common things that are backbone of your platform going to be. And you can see the Git repository structure actually on the right side here. That's like core as a realm, integrations as a realm, then the workspaces as a realm. The pipelines is not a realm. We will see it later. That comes from the template. And under those realms, we have a multiple like projects, common data sets, security policies, and zones, VNets, and so on. And realms and environments are like I mentioned about environments, but I didn't talk about it. So between Terraform plan and apply stages, we introduce a manual approval step. And for that, we utilize Azure Pipelines environments, because that's currently the only way how you can have manual step actually there. Maybe something changed, but at least like 1.5 years ago when we're building this, it wasn't, nothing else was available. So you have to use like environment. And you can create an environment per each Terraform project that you have, but we create them per realm, because if you create it per each Terraform project, then you have like hundreds of projects, you have hundreds of environments, it adds a lot of like management, because for every environment, then also you need to add approver group. So it's a lot of hassle. That's why we do it at least on the realm level. So if you have integration realm, it has integration environment for that realm, and there is approver group for the whole integration. So the people who are responsible for checking that whatever Terraform is trying to do before plan and apply phases, that it actually corresponds to, like, is doing exactly what is expected. So your developers can actually use this to run the pipeline and actually try to create something new, but then someone will be checking it really to see if this is accepted within this realm or not. And there is, for as an example, list of environments that you can have for prod, test, and hub subscriptions, different like realms, everyone having their own. And let's go to the demo. So we are kind of over the presentation itself, though I still have a couple of slides to show. So let's go with the demo. And I'll start with bootstrapping the Terraform resources. And while it will take, because it's going to take time, I'll switch into the slides to explain actually what is it actually doing. So now let's go into resource group. Let's check that actually, yeah. So as you can see, this has been deleted. Let's close this. And let's now open our DevOps project. So like kind of take a look into what we were talking about. So here is DevOps organization. It's called after my initials, Yuri Barseghyan. So that's the name of the organization. And here I can have multiple projects, and repositories belong to projects. So that's why you can separate repositories of different customers to its own project. Under organization settings, there are various kind of settings that how to configure your organization. But maybe one thing to take a look into is the agent pools. So under the agent pools, we have the this is the Microsoft managed agent pools. Like you don't have you can use the agents, but you don't have much of a control over them. Let's put it this way. But of course, through these extensions, you can install some software on it. And then you have self-managed ones. And because we want to do the our security model is such that we want to be deploying to the environment from within the environment. So that's why we are using actually like the self-hosted agents, which are running in customer environment itself, because this way connection towards Azure DevOps. So Azure DevOps doesn't really have inbound connection to your subscription. It's the agents who are connecting to Azure DevOps to pull the jobs that they need to run. And they just need outbound 443 connection open for it. And yeah, so, and like we will take a look actually into this one like later on. So to be able to bootstrap the project, we need to use, I prepared a template here. This is like open, you can, it's in a list of resources, you can take a look into it later on. So we'll need to clone this repository, and I actually have it cloned already. Let me see. Yeah, I have it cloned, so we don't really need to do it, but I'll actually show what's under. Oh, why did I go into full screen mode? Yeah. So yeah, it has a bunch of resources. So again, let's take a look on the slide. Not really here, but what we need to do here is create a folder called vars, because this is a generic Bootstrap project for bootstrapping resources for all of your clients, and you are using exactly the same project, exactly the same set of resources. So the way how we will be distinguishing between of them is by having like a tf vars file, which is like variables applying into this one. So let's call it faug demo tf vars, and I'll copy an example of configuration like this, and let's replace the backup with faug, and this one, let's have it big. And now I can just do Terraform. I would need to do Terraform init, but Terraform init is already, or actually let's run it, Terraform init. I have already locally everything downloaded. Yes, so all clean. Now I need to run Terraform, or let me actually copy. I don't want to do any mistakes. Where is it? Terraform plan. Yes, and let's make sure, yeah, Terraform there. So I'm running the plan with my values file. And I actually skipped a couple of steps, but I will show them while it will be bootstrapping resources. So it will create for me 17 resources, quite a lot, and it has some output, which we are going to be using later on. So all looks good, so I will actually apply this. And let's see what we actually missed. So to be able to, because we are going to be communicating with Azure DevOps as well, for that we need a thing called personal access token. And personal access token is something that lives here. And the problem with this is that you don't really have in the DevOps at the moment anything like a service principals or service account. So those are really personal. So now if I create personal access token and use it in this bootstrapping, everything visible, like all the agent pools that we will be creating will be created by me. So you can't really kind of make it non-dependent on the person at the moment. That's a bit of a problem right now. So yeah, let's say run it. And what we need to do, like I have it already set up, but I'll just show the steps. So you go into the personal access tokens. And here you will need to create a new token. I have one already. You can specify like expiration for how long it's like valid, and you need to set, the only thing what we need to set for this, for our Bootstrap to work, is agent pools scope read and manage, because our Bootstrap project will be connecting with Azure DevOps and try to create agent pool for us that it will then register agents under that agent pool. And because we have agent pool per customer, so every single customer will require its own. So that's why this is really needed. So I have one, but if you generate such a token, then you can actually use it, or you need to set it up under your bash RC or ZSH RC, whatever you are using. I'll just show example of it. And it goes in the end. I'll move it here. So you need to have those for the DevOps provider to work. You need to have the org specified. So this is the URL for the other organization, and this is a personal access token. And one other variable that we are using just to automate that it's not going that the Terraform Bootstrap will not ask you every single time. You can using this tf-var prefix like to set up any kind of like variables that you want as the environment variables. And this Azure DevOps path is something what we are using in the project under variables. So it's one of those Azure DevOps path here, this one. So this is the way how we can pass it, that it will read from an environment variable. Yeah, so that's about it. So this is what needs to be done to set it up. But yeah, and another thing, yeah, of course, missed is that to be able, of course, to work with the environment, you need yourself to be connected. So you need to have AZ CLI installed locally, and you need to have the connection. You need to log into the subscription, and you need to have that one like active. So if you list the subscriptions, that one should be the active subscription and should be the one where you are actually deploying this. And currently I have that set up with the subscription that I have been showing you earlier. So yeah, and let's go into actually the slide and show what is it doing. So currently it creates like Kubernetes cluster. This will take some time. Usually it's 5 minutes. So we have some time actually still to do. So here is the bootstrapping part of Terraform resources. So you as a developer from your machine with your account, and you need to have owner or contributor plus user access administrator right towards the subscription where you are bootstrapping and which you are planning to manage. So you need this only during the bootstrap phase. Afterwards, because Terraform is the one which is going to be running everything for us, you don't need to do it. So if subscriptions are usually managed by someone else and you don't yourself, you are not the owner, you need to ask your customer for some time being add you contributor and user access administrator rights to the subscription. So what project will do is that, again, using your accesses, it will communicate. So we run the Terraform Bootstrap project. It will communicate with the Azure subscription, with Azure DevOps organization, and it will create under Azure DevOps organization the agent pool. I actually will show you it because it should be already there. So if we go into organization settings and look into agent pools. So here is the Fog demo agent pool, and this is the one that we gave a name to be, like here is the Azure DevOps agent pool, Fog demo agent pool. So this is the agent pool that is getting created. So this is the first thing. So it just creates empty like agent pool. And then it communicates with Azure subscriptions, or is doing it actually in parallel and create a bunch of resources. So within the resources, it actually creates a Terraform resource group where all the resources are going to be. It creates a storage account where your Terraform state files of the projects that you will be later on running will be hosted. So for the remote state, saving it there. Then it creates a VNet, binds those together that the storage account is accessible only from the VNet. It creates a user assigned managed identity. It assigns to the user assigned managed identity contributor and user access administrator rights to the subscription that we can utilize then this automation to actually create a bunch of resources and actually do the role assignments to them as well. And because we are doing a role assignment, we ourselves need to have the user access administrator rights to be able to do that, of course. And then it creates a AKS cluster. When the AKS cluster has been created, as a next step, it will actually download it's going to use actually Helm provider. It will download the Helm chart from a repository that is, again, I provided the link. We can take a look into that later on, which will fetch a Docker image, or it's not really fetching, but it's kind of using a Docker image that, again, was created by me. It's also like public. You can use it. And it will deploy this Helm chart into the AKS cluster. The deployment will create for you multiple pods. Those are the things that are actually running. The self-hosted agent, and they will register towards the created and provided agent pool. So most probably all that is now done. So we can actually take a look on how it looks like. If we go here and to check agents, you can see actually that 2 of them are running. So this is done as a last step, that agents are registered automatically. And as you can see, we didn't need to do anything. Like, it's all run by the Bootstrap project. You don't need to go and click anywhere and like create anything and provide anything. So yeah, it has been created. And what we need is we need the output. We need to save this output. So actually I will save it somewhere just in case if we are going to be losing it. And we go to the next step. So as a next step, we will now create actually a project for our customers. So if you imagine that now we are onboarding into Azure new subscription of our customers, so now we have automation, Terraform automation resources created. And actually, let's take a look into what has been created again here. It's, let's also, Fauk. Oh, sorry, Fauk. So here is the resource group. And under resource group, we have bunch of resources created. Let's close this one. So the storage account I manage. Yeah, there are some other things as well, but they are just there to help you for log collection, like log analytics workspace, and some other like solution for like exactly like having monitoring for your Kubernetes cluster and so on. But this is managed identity. This is your virtual network, and this is the AKS cluster actually, where the pods are running, which are connected into the Azure DevOps agent pool. And now, if you think that like this is exactly what's created, this is the state of your subscription gonna be, so there is nothing else except this, and now we want to start creating actually resources, so like VNets and so on. So how we do that one? For that, we have another project template. It's called Terraform multi-project template. So let's start with that one. So we go into the demo, git clone this repository, and Terraform template. Of course, you will need to rename all this kind of stuff actually. And actually, that's what we are going to do. Yeah, because we need to go into our organization and create your new project. So I will create a new project. Let's call it Faug demo. Create it. Then what I need to do, I will need to add our agent pool, make it available for that project, because we create agent pool without automatic registration and availability for all of our projects, because we really want to use agent pools of the customers only for specific customers. We don't have the shared one. So if you have customer 1, customer 2, you shouldn't be able to use agent pool of customer 1 to deploy to customer 2 and vice versa. So that's why we are not really sharing those Azure DevOps agent pools by default for all the projects, and that's why we need manual. So this is where it gets a bit kind of a manual stuff when you are setting it up, but usually you just need to do it once. So here we are under Faug demo project. I need to go into the add agent pool and select existing and say that I want to make Faug demo available under this project. And I'm not going to grant access permission to all pipelines, because if you think that you have like test prod and hub subscriptions, let's say multiple subscriptions, you want to use agent pool per project, per repository, and not like that you are again being able to deploy to the dev using a hub and so on. So that's why this we deselect actually. And that's why we have agent pool per environment. Okay, this one is ready here. So next what we need to do is create a repository under it. So let's go into the repos, and okay, let's just use the default one that it's creating. So I'll just use this one. And let's go here, git clone. Oh, sorry. Yes. So let's go into let's go into our multi-project template first, because I'm going to actually copy paste from one to another. And then I need to open the Faug demo one. So our Faug demo is empty. There is nothing. So I will actually select those 3 everything what's under this one and just copy paste it here. Then we don't actually need this one. And this is exactly now the project structure that I've been showing to you, with the set of the realms, and under realm having a projects and so on. So as a part of the setup, what we need to do, because we want to use Azure DevOps pipelines, we have actually the template for the pipeline, which looks something like this. So it's actually kind of pretty big file, and it has, so this is the YAML Azure pipeline. So we have multiple stages, actually 2, not multiple, stage plan and stage apply. And we are using environment in between of them. Here you can see, so it's all parameterized and so on, that we want to kind of like do the manual approval. And there is a bunch of parameters, and this is the thing that we need to update. And again, this is done only once. And for that, there is a separate file. This is the one. And here, as you can see, there are missing defaults. So we need to fill it up. And for that, I need the values that I have been having from as output. So here is it. So SA resource group, it's a storage account resource group. It's this one. So a bit manual labor, but just not so much. Storage account name, storage account, here is the one, container, TF state, tenant ID, here, subscription ID, this one, MSI ID, so this is the managed ID, the user managed identity ID created for us, and Terraform subnet, and the pool name. So those are configured here. And after this now, so this one has been configured. And again, you do it once, and all the projects are going to use exactly the same template. So you don't need to do it for the rest of the project. So we can close this one. And the next what we open is we go into the realm, and let's rename it. So let's say that this is the core. But with that one, when we rename the core, we need also to rename corresponding the pipeline template. Or actually, we don't need to rename this one, but we need to provide approval environment here for this specific. As I was saying, we have approval environment per realm, and our realm is core. So now we need to create a approval environment for it. So let's say that it's going to be name. We can name it whatever we want, but of course, it's nice to have the realm name there. So this is the name that we will be using. And for that, I go into the pipelines, environments, and actually create the environment and give the name to it. And there is like, this is known, environment created. Now we want to have approvals and checks set, and we want to set approvals. And here I'm going to set myself, but you can set a team or whatever. You can create like a teams from the project settings and create multiple teams per approval environment and so on. So, but here I will just add myself, and here you can give some instructions that will be visible for people who will be need to approve. So let's say, please check the plan or something like it, and create. Okay, this is set, so the name is correct, and after this we go into the project itself. So per realm, this is again need to be done once. This template is using the template under the pipelines, referencing it, and then we have exactly the same pipeline folder here under the project itself, and this will be referencing our realm pipeline file. Actually, that's how they are actually getting to use the common configuration. And what needs to be done here, and this is very important, and that's why we actually use, for example, Yeoman generators for exactly these purposes. And I'll actually just have a small demo. That you need to have a specific, for example, because this is a triggering for our Git that the pipeline will get automatically triggered. We, of course, want to specify specific project. So only if within the project the changes occur, then only to trigger it. And because of that, we need to specify this as a core. So as a main folder is core, and this is a project Y. So let's keep it, maybe let's rename this into something more kind of useful. Let's call this actually like VNets. So this will be one of our main. So we need to rename also the project path. These are quite important things, so that's why better to automate this. As an example, I'll show how you can automate it. So you can create a simple Yeoman generator, which will be actually, this is the correct one. TDP infra. This is created ourselves, new. So you run this one, it will check what kind of realms you have actually here. So at the moment we have only core, so you can select only core. If you will have more, you can select where you want to create your new project. You select this and then project name to be created. Let's create project which we will be using later on and name it like zones, for example. And for me, it will actually create the pipeline file. So here we can see the folder created. It will create the pipeline file. It will render it correctly with all the correct values. And it will create for me also main TF, which has like some default configuration that you can already start with, and you don't really need to build this yourself. So this way you can also like actually enforce the teams, not really enforce, but like try to use the same versions of the providers, for example, across the project. So if you will check like main TF, this here and here are exactly the same. So like this is like a base for you. Of course, you can add more providers, remove some of them if you are not using, but this helps you for like bootstrap the things and make it faster. And by creating the pipeline file for you as well, it kind of makes it kind of less of the copy pasting errors, that if you forgot to provide the correct names here, that there will be no any problems. And the project path is very important because that's how we are actually, this is the one defining the name of the state file within the storage account. So you really want to make this unique, of course. And that's why we enforce to use the same Git repository, that you can't have a same realm name, same project's name, and you really need to be careful when you copy paste the projects. That's why in our team, for example, is always recommended to use the Yeoman generator and not really copy paste around. So now we have 2 projects, and what we need to do, create Azure DevOps pipelines for it. So first we need to push everything. So initial commit, push, and what? Cancel. Okay, let me see what's the, sometimes this gives you commit, undo last commit. Let me do it actually from here. Git push. Because of tip of your current branches, be okay. Git pull. Okay. I don't want to really go into this detail, so let's actually, I'll just show you example, and we can check how it has been already done. So this is the place that I don't like with these demos. So here I have actually an example already. Oh, sorry, this is the wrong one, not this one, but so our backup. So I have backup demo, cd backup demo, open this one. Oh, actually, yeah, it was the same one. Yeah, it's just like quite a lot of resources. So as you can see now, we have like core, which is our realm, and under it I have actually 3 projects: VNets, workspaces, and zones. So the VNets just will be creating, like we can take a look on what's there. So it creates a resource group, and it creates then within the resource group the VNet internal. So internal VNet, and we'll create one subnet for like a Databricks for being able to create Databricks. So actually 2 subnets, yeah, for public and the private zones. So this is the first project VNet that we are having. Then we have a zones where we are just creating different storages, like data zones. So here in this specific one, I actually create only one zone called storage, and open the connection to the Databricks public subnet. And in main tier, we can see that we have a reference to the state file of the VNets And this is where, again, the automation is very handy. There are quite a lot of variables that are set from the pipelines for us, and we can just reuse them. That's why we've been outputting everything that we can later on reuse the reference, the state file. And the only thing what we need to change is the key itself, where we reference to the project that we are using. So this vnet under core vnets, and we are referencing that we want to read this specific state file. And because like that's read into through the locals, and we get access to the vnets, and then when we set the storage zone here, we can utilize the subnets to put it as a service endpoint connectivity from the vnet into the storage account. And similarly, then we can have a workspace where we are actually creating a Databricks. And because Databricks is the Databricks resource needs a public subnet, private subnet, and the virtual network itself. So those are the ones that have been creating in the VNet project. So we need to reference the state of that project. Again, here VNets and core VNets. This is the remote state reference. And then we can create the Databricks itself and the resource group for it and so on. So how the pipelines actually look like. So now I need to change the project because this is not the one. It was the backup demo. And under backup demo, in the pipelines, I have another environment, core approval environment. And in the pipelines, I have like 3 pipelines, 1 per project. And I'll actually just show you how you import a project, because you have a code, you just need to create a new one, import. So you say new pipeline, you say my pipeline is in Azure repos Git, you reference which Git repository it is, you say that the YAML file already exists, and here you need to provide a path. So if your project is like, let's say the workspaces, then you need to copy a relative path to this one, Terraform apply pipeline file, like this that was innermost for the project, and paste it here. And you say continue, it will read the file, and then you can say save. Then it's a good practice to straight away like rename it. So usually like we create, because there are multiple realms, we create actually folders per realm and so on, because like name, as you can see, it's like sometimes very stupid. So it's good idea to actually, sorry, wrong thing, not edit, but rename and move. And you can give something more meaningful, like let's say core VNets, or let's say even environment, like let's say prod core VNets. This will be the name of your pipeline. And if you run the pipeline, then it will ask you to permit the approval and so on. I can't really demo it now because this has been done already for those, but like I'll just show how it looks like. So you have a core. Let's go into the VNet one. So here is your pipeline. I've been running it multiple times, as you can see. And if I say run the pipeline, you can actually, if you are using during the development remote branches, you can like specify the branch where your code is. But we have usually, and it's a good idea to protect deployment apply phase, that apply is only run from the master. Otherwise, then you will have a bunch of like within one repository, bunch of branches, and partially it's applied from master, partially it's from branches and so on. So you can't really copy paste to one specific repo config which represents the whole your subscription like environment. That's why we usually in the pipeline have the locking for that. I'll show you that part. So between the projects, you can see here there is for apply phase condition saying that this is allowed only if your branch is master. Yes, and you can say run. Sorry, I forgot to show you the stages. So you can actually, let's go back. When you are running the pipeline, you can select the stages as well. If you don't need to apply anything, you are developing, you want to test some stuff, you can select apply and only run the plan phase. And for me, this will be running the plan phase. We can follow what it's doing. Whoa, we have some errors. So let's see what it says. Terraform init doesn't work. No, it doesn't want to show me. Okay, fail to get existing workspace. Okay, let's just rerun this. Sometimes there are these kind of errors. But I'll maybe show actually how it looks like from the resources perspective. So what has been created. So those are the things getting created. Backup VNets is the thing that is created by the VNets project, workspaces by the workspaces project, and we have also this storage zone. And if we look into how the state files look like and where they are, we need to go into backup demo TF infra. So this is our infrastructure resources. Here is our backup demo TF infra SA, like containers, TF state. So this is the container. And here you can see that we have folder core, and under core we have 3 state files for each project. So again, we are trying to keep exactly same structure for the state files as we have the structure within the Git repository itself. So most probably that's it. Yeah, I mean, this is failing for some reason. I don't know what's the problem here, and no time for, it's already 1 hour. So maybe we stop just here. So let me see if I have anything else to show. So this is done. Yeah, there is a list of resources. So you can like read about Terraform. There is a reference to the Docker image, Terraform infra Bootstrap repo, to the multi-project template that you can use, same that I've been showing. So those are the different resources. And I guess we are ready for questions. So let me switch into YouTube and see if we have any questions. So Pasi has been asking, how do you handle the upkeep of the self-hosted agent image, tooling and security updates, etc.? It's a good question. Actually, we don't really much. For example, we had the agents that have been running for quite a long time. One thing what you could do in the Helm chart itself, we don't specify what's the version of the agent that you deploy. So if you rerun the Bootstrap again, which will redeploy the Helm chart for you. So it will delete all the old agents, and it will install for you the new agents, and for that it will like pull the latest image. There are all the references for how to install, run the DevOps agents in the AKS Kubernetes, so you can take a look into that. And like we just use reinstalling it and trying kind of to run exactly like the latest version, which will be just pull image that itself does not contain the self-hosted agent. So during the upstart, it will connect, it will download the latest versions. And of course, the best to keep all those like binaries at your repository, maybe, that you will not have any kind of internet connection problems, let's say, when you are trying to start it and so on. But yeah, so like we actually handle it that way. So yeah, security updates then will come from that. And of course, like then you have like security for the AKS, and then upkeep of AKS, and update of the version of the AKS and so on. So the template that I have is not like full blown containing everything, but you can use that to build a lot of stuff on top of it for like upgrade of the AKS versions, expose it through variables and that kind of stuff. So yes, so that's it. And I think there is no any other questions. Maybe I'll wait for some time to see if there will be anything. But otherwise, if not, then I think that's it. So thank you. And the presentation at least is over. Okay, one more question. Variables library, which I'm not really sure what you are referencing as a variables library. If you mean the variables from the Terraform itself, then of course we are using it. So for example, here, every single project itself usually consists of like we are rendering for you the or like through this Yeoman generator, the pipeline file that you can use for importing creating automatically the pipeline for you, and the main TF file. But the rest is something what you just write a normal Terraform code. There is nothing else. And here usually you will have like your variables TF file that you will describe what is the inputs for that specific like environment and project. And if you have exactly same infrastructure in every single customer use case, which you will have, like as I explained, in the data platforms, there is quite a lot of like main components like a VNet. So you will actually kind of create a module out of it, and then you will exactly use variables to assign, create specifically like prefixes, like what is prefix used in this case for every single resource you are creating, what are the tags that you are applying, and location where it needs to be deployed. And for example, in this case, I use Terraform TF vars to provide this configuration. So the workspace project itself can be exactly the same between all of your clients, but the only difference will be in the Terraform TF vars file that will change between customers and between the environments of the customers. And same way in the Bootstrap as well, we are using variables. So there is like tons of them. I have many default ones. So that's, of course, if you are using, you need to replace, you are not going to use my other organization. So you can replace the default ones. And then through the TF vars, I'm giving like specifically the stuff that I want to, what's the difference from the default for this specific environment. So hopefully that answers the question. In the pipelines. So in the pipelines, I mean, there is no need in any variables because everything I can actually show. I'm using parameters, and the parameters is something that are, I mean, we don't really want to too much customize because it's always plan and apply, and we don't try to create two custom pipelines. So this is default that is given for the infrastructure part, and there is no really need in the using of variables. And like the only thing what we use is the parameters, and the parameters are here. So this is the only place where you set up the parameter, or not the only place. I'm lying. So this is the part that is set in the core part. And approval environment and project path, they come from respective realm in the project. So approval environment parameter you set up under the realms pipeline. So here is the place there where you specify and kind of hard code it for the whole realm. I mean, you can modify again. If you want to have environment per project, then you will move this approval environment template, the parameter definition under your project. It will define it under workspaces pipelines. But because we use one approval environment for all the projects under that realm, we specify it here. And then the only thing was left is the project path, which is set up under the project's pipeline itself. So it's set up here. So between projects, the only things that are changing is the project path, and on the realm level, the approval environment. So, okay, great. So yes, if no more questions, then I guess we can end this. And it took a bit over 1 hour. I mean, this is not, hopefully this was clear also because it's very many layers, let's say. And if you have any questions, just ping me in LinkedIn or just call, I don't know, message me. You can find me like in Twitter, LinkedIn, wherever you want. So that's it. Thank you very much. Bye-bye.